Hello everyone and welcome to another webinar by Royal Cyber. My name is Ali and I'll be your host and one of the speakers for today. Now some ground rules for a smoother experience before we begin. If you cannot see my screen or hear me properly, kindly notify me at the chat window on the right side of the pan. During the presentation, you can post your questions and comments in the chat box anytime. Also, there will be a dedicated session for question and answers towards the end of this presentation. Your questions will be answered in the sequence in which they are received. Additionally, you can post your questions or write to us for a follow-up information on the email ID, which is info@royalcyber.com. And finally, we would love to hear back from you about today's session by completing a short survey, which will be shared towards the tail end. Okay, so in the next 50 minutes, we will discuss how to simplify migration of APIs using the Mule Migration Accelerator. This is the accelerator developed by Royal Cyber, in which we'll be able to showcase to you today that how to migrate your APIs in different environments. Okay, now to present this topic, I'd like to introduce the speakers. By the way, that's me on the top row. My name is Ali. I'm the practice lead for middleware, focusing on helping customers to get the best ROI on the digital transformation journeys. Along with me are two of my great colleagues, wonderful friends, and a knowledgeable speakers, Mr. Haider Raza. He's a senior technical architect at Royal Cyber, and followed by him is Minhajul Arfin, who is the senior technical lead at Royal Cyber, and both of these are the brains behind this solution as well as the accelerator. Now, let's have a look at the agenda for today. So we'll go through the introduction of the organization. We'll get an overview of Royal Cyber. We'll see different scenarios and options for migration. We'll review and discuss these use cases, that what sort of use cases are there for migration. We'll talk about best practices and considerations within that division. We'll see how and why do we need to migrate using this accelerator and what is the benefit that a customer is going to get or you're going to get at the end of this session. Then we'll talk about some of the use cases which are supported, followed by the return on investment and benefits, and then the demonstration, where you'll be able to see the solution in action, and then question and answers towards the tail end. Now, first thing first, let's have a glance at Royal Cyber. We're a mid-sized IT consulting and digital transformation company specialized in services, solutions, and softwares. We have over 2,500 plus employees globally. Our headquarters is in Naperville, Illinois, and we have a global presence with offices in Canada, the UK, Australia, and the Middle East. We do have multiple offshore development centers in India and other Asian countries. Our strategic partnership with several technology companies provided best-of-the-breed software and solutions such as MuleSoft, Salesforce, SAP, etc., coupled with business agility and following the Sun delivery model makes a Royal Cyber an obvious choice for most of our customers globally. We have some of the awards and recognitions as well. We are ISO 9001, 27001 certified. We are Best Employer of the Year awards that we've been awarded with the Best Employer of the Year as well. And we have some other recognitions as well. Now that being said, I'm going to hand this over to my colleague, Mr. Haider Raza. He's going to move you forward with Mule migration scenarios and option.
Thank you, Ali. To kick off our webinar on MuleSoft migration, we will be exploring the essentials and latest advancements in MuleSoft deployment models. Today, we will discuss moving from older environments to the newest deployment options, including from Runtime Fabric RTF Appliance to bring your own Kubernetes, BYOK, as well as transitioning from CloudHub 1.0 to CloudHub 2.0. We will delve into features, benefits, and best practices for each platform, aiming to help you make informed decisions about modernizing your MuleSoft deployments efficiently and securely. You will notice that both RTF Appliance as well as CloudHub 2.0 are mentioned twice. indicating that we will be dedicating some more time to these options from a migration perspective. As far as RTF Appliance is concerned, we have already passed both the standard and extended support periods and are now approaching the end of life support for RTF Appliance as well. As a result, migrating to other deployment options has become a necessary step forward. If you prefer to migrate from RTF Appliance to RTF Self-Managed Kubernetes, there are several options within RTF Self-Managed Kubernetes space. Let's discuss them in detail. If you prefer to migrate from RTF Appliance to RTF on an existing public cloud managed Kubernetes service and have some level of expertise in managing a Kubernetes cluster, then RTF supports the following public cloud managed Kubernetes service, such as EKS from Amazon, from Google GKE, from Azure AKS, and then there are several options from Red Hat and also Alibaba Container Service for Kubernetes. If you prefer to standardize your own bare metal solution using public Kubernetes distributions, depending on your affinity to public clouds and in-house Kubernetes expertise, the offerings on the right are available. One good thing that has happened is that in RTF Appliance, apart from port-based licensing model, we now also have message and flows-based licensing model available as well. While if you prefer to migrate from RTF Appliance or Cloud Hub 1.0 to Cloud Hub 2.0, then Cloud Hub 2.0 is a fully managed containerized integration platform as a service iPaaS where you can deploy APIs and integrations as lightweight containers in the cloud. It supports a shared space setup, which is an elastic cloud of resources that includes Mule instances running in a multi-tenant environment. It also has a private space setup, which is a visual private and isolated logical space in Cloud Hub 2.2, which you can consider as a VPC, and this can run your application. You can create multiple private spaces either in the same or different regions. The diagram shows the architecture of private space setup using a combination of ingress and load balancers, and you can restrict traffic to your APIs for only internal consumers or open it to both internal and external consumers. And you can also connect to your on-prem or private cloud resources through transit gateway or VPN tunneling. Let's also touch the Flex Gateway deployment option, which is an ultra-fast design gateway designed to manage and secure APIs running anywhere. Flex Gateway comprises two components that work in tandem. Basically, it has a control plane here, and this helps. This is hosted by MuleSoft, and it centralizes management and observability, enabling you to build APIs, add policies, deploy APIs into runtime, monitor APIs in Anypoint API Manager. And then it has a runtime, which is a customer-hosted distributed entity, is installed in any cloud or data center. The runtime receives commands from the control plane and routes and protects the backend APIs. Built with security in mind, Flex Gateway secures communication between the runtime and control plane through mutual TLS and HTTPS. There are several benefits for going with this deployment option, such as extending endpoint platform benefits to any API. So you can manage any service, no matter the size, language, or cloud, while providing consistent enterprise security and manageability across all environments. You can implement any architecture, which means you can manage any service across any architecture, from microservices to monolith, with a gateway that can be deployed anywhere, including cloud native and containerized environments. It is ultra fast. It integrates well with your DevOps CI/CD pipelines. It is like secure with zero trust by default, which means you can configure a robust set of authentication, security, quality of service, traffic management policies with zero trust implemented by default. and then and governance, where you can secure, engage, discover, or govern both Mule and non-Mule APIs. So let's compare these various deployment options. As far as managed responsibility is concerned, Cloud Hub 2.0 is totally managed by MuleSoft, while the other two options work on a shared responsibility model where control plane is hosted by MuleSoft, whereas the data plane is the responsibility of client. APIs per core, Cloud Hub 2.0 provides like fixed slot of replicas, which you can choose as per your API needs, which has like fixed amount of CPU cores and memory. You can deploy like flexible APIs as far as RTF is concerned, while Flex Gateway works on API volume. Global deployments, case of Cloud Hub 2.0, if you want to change a region, you will need to like set up configure a new private space. While in case of RTF self-managed Kubernetes, you have to like replicate the whole setup to the new region. And in case of Flex Gateway, like it's very flexible and you can easily set up the Flex Gateway data plane anywhere as per your requirement. As far as cost is concerned, since Cloud Hub 2.0 is fully managed by MuleSoft, so this may be a little higher. While in case of RTF, it works either on cores or on base of volume, that is based on the number of messages and flows that you have. And Flex Gateway also works on the basis of volume of API requests. Kubernetes skills are not required for Cloud Hub 2.0, but we require them for self-managed Kubernetes. Case of Flex Gateway, if we are using Flex Gateway as a Kubernetes ingress, then we may require some Kubernetes skills. Memory available to APIs is not limited for Flex Gateway and self-managed Kubernetes, and the APIs can use the available memory that we assign to the infrastructure. In case of Cloud Hub 2.0, like you have like this amount of memory for the replica size that we select. Multi-cloud deployment, Cloud Hub 2.0 is AWS specific, but we have various options for Flex Gateway and self-managed Kubernetes. Let's explore some other factors that influence your choices and help make informed decisions for the future of your deployment. Obviously, first is the core consumption assessment. You need to like do some assessment, like if you migrate from RTF appliance to Cloud Hub 1.0 to Cloud Hub 2.0 or RTF self-managed Kubernetes, what would be the total core requirement? Backend systems and SaaS services, basically integration backends for your integrations like databases, ERPs, warehouse management systems, etc. are important, because if you move your integration platform to another cloud, this will impact MuleSoft API latency and require the detailed analysis of the specific architecture, region, integration, and the nature of data transfer between the systems. And it is essential to consider factors such as inter-cloud communication and data transfer costs. Availability of technical skills, especially for private cloud Kubernetes and ingress management, if you are going with the Kubernetes self-managed Kubernetes option. Data residency and compliance, ensure compliance with data residency regulation, especially if the movement involves crossing international boundaries. Cost of managing self-managed Kubernetes, you need to consider that in case you are going with RTF. And last, we have security and control, where like some customers may have like some preferences, like if they want to like how deploy and manage an in-house solution instead of hosting a cloud solution. Next, let's review some recent Royal Cyber migration case studies across various deployment options to get a clearer picture of how these migration projects might unfold. First of all, we have a global manufacturing solution provider, and in this case, we migrated from RTF Appliance to Cloud of 2.0. Based on the volume and current CPU and memory utilization, we projected the core requirements for a potential move to either Cloud of 2.0 or Runtime Fabric. The Cloud of 2.0 option was more feasible for the client as it would alleviate the need for additional administrative responsibilities related to managing a Kubernetes setup. And also, the number of APIs and their current usage and core utilization was such that most of the APIs can be easily fit into the lower tier of replicas that are available in Cloud of 2.0. Then there were like different solution design questions that we needed to focus, such as since client was opted for Cloud of 2.0 and they were basically connecting to their on-prem data center, they had a preference that they don't want to route traffic directly to Cloud of 2.0. So they wanted that the traffic should arrive at their single point of entry, that is their on-prem data center, and from there through VPN, it should get routed to Cloud of 2.0. So they wanted a single point for this setup. They wanted to maintain their existing F5 load balancers to avoid impacting internal and external clients who are currently consuming their services. That is, they aimed for minimal disruption during this migration. There were discussions around using VPN or transit gateway to ensure the setup aligned with their security architecture, allowing for comprehensive traffic control. So just to mention that Cloud of 2.0 only supports two options that are VPN connectivity and transit gateway, through which you can connect your Cloud of 2.0 setup to your on-prem data center. After these solution design aspects were resolved, we moved to the applications, and there were some minor changes that were required. Basically, RTF basically has a built-in support, RTF Appliance, to forward logs and metrics to your external enterprise logging or monitoring solution. But that is not the case with Cloud of 2.0 or RTF. So here we need to configure the log4j files of individual applications to forward the log to external log solution. Inter-application URLs. Additionally, there was a need to transition from F5-based URL that the client was earlier using in RTF appliance to a more localized URL, so that the traffic remains within the private networks setup. Because these F5 were residing in the data center. So if we keep on using the same F5-based URLs, then there will be like extra redundant traffic hops that would increase the latency for the migrated APIs. So apart from these application changes, in parallel, we set up two private spaces, one for non-prod and then another for prod, and we set up VPN connectivity for both the private space to the data center. We tested connectivity from Cloud of 2.0 to on-prem data center and from on-prem data center to Cloud of 2.0. And in the end, like obviously there were application access and testing, so that like the applications that are deployed in Cloud of 2.0 can access the enterprise resources that are residing in data center and various clouds. And finally, after all this application testing and performance testing and the functional testing, we move to the production. So the second case study that we have is for a client which is a top US mortgage lender specializing in residential loan services. The main challenge over here was the client was running RTF appliance in AWS cloud, and the obvious option for them was to move from RTF appliance to RTF self-managed Kubernetes, that is RTF EKS again in AWS cloud. There was a challenge here, like client was expecting us to do this migration with minimal code changes or zero code changes, because the development team was already busy with high priority feature implementation, and they didn't want to assign resources for any changes. So for this purpose, as we discussed earlier, like RTF appliance has a built-in ingress controller load balancer, but for self-managed Kubernetes, we need to select and configure ingress control load balancer. Here we carefully selected a combination of AWS ALB and Nginx controllers so that we can avoid any URL changes that are required for this migration. Obviously, data center connectivity was required for accessing different resources that are running in different cloud, as well as client also has CloudHub 1.0, so we needed a connectivity setup between CloudHub 1.0 and RTF EKS. For infrastructure setup, we basically used Terraform, and then we used CI/CD jobs as well. So whenever we push some infrastructure changes, for example, if we are updating the Kubernetes version or RTF version, then the CI/CD job will automatically kick off, and it will deploy the whole RTF EKS setup again. Then we move to application changes, such as enterprise logging. So we basically used and configured FluentBit to forward logs to CloudWatch, and inter-application URLs, we basically use the same URL that were there in RTF appliance. Apart from these testing, there was some performance issues that were observed post-migration. Basically, when we migrated from RTF appliance to RTF EKS, there are few differences. In Kubernetes version, RTF version, the operating system that was being used, its version, and RTF EKS nodes were also hosting some extra services which were previously running in RTF controller nodes. But now those services were running on RTF EKS, which were putting some extra load on our worker nodes. So basically, we needed to tune APIs for heap and core values. And we also observed that APIs were using a custom Log4j connector, and we had to change that to the default Log4j connector to stabilize the overall system performance. So these were some challenges in this RTF migration. In the last, we have a case study on CloudHub 1.0 to CloudHub 2.0 migration. Client is a leading US mattress retailer offering a range of mattresses, bedding accessories, and sleep products from top brands. We started with a sizing exercise, and basically calculating how much VPC or private space we would require, number of VPNs and cores that would be required for this migration. And this was a comprehensive migration project where we were responsible for all the overall execution, including effort estimation, infrastructure design, code modifications, compute QA, covering unit testing, SIT and UAT, and finally the production cutover. So apart from this migration from CloudHub 2.0, we were also doing some extra work over here in this migration effort. So another component that we had was the Java 8 to Java 17 migration, and it had its own some challenges. Basically, we needed to migrate. When we are migrating the APIs, we needed to upgrade the connector versions. So we use the latest version for different connectors such as SFTP, database, Spring Security, S3, API proxy, and custom policies. We just mentioned these some connectors because we faced some issues specific to these connectors while upgrading to the latest version. And then we were also another migration component is migrating the runtime. So Cloud Hub 1.0 was basically using all APIs on Mule Runtime 4.4.0, and we wanted to migrate them to our latest version, which is 4.6.5. Apart from that, there were some other migration components in this project. Basically, client was also moving from AWS to Azure. And since apart from Cloud Hub 1.0, customer was also having hybrid runtimes that were hosted in AWS, and we needed to also move those hybrid runtimes from AWS to Azure. And again, we need to set up those hybrid runtimes on the latest Mule runtime, which is 4.6.5. And then there were some other related services that were being also migrated to Azure, such as the SQL Server, the managed SQL Server instance from AWS was being migrated to Azure, and also we were using AWS Elasticsearch, so that was getting moved to Azure Cognitive Search. So all these were different migration components in this project, which made it like a bit complex migration effort. But we successfully achieved all these infrastructure changes, runtime changes, Azure migration, apart from and along with the required application changes, connectivity testing, application access, like these applications were accessing different internal and external systems. So making sure that applications are working properly with respect to functionality, as well as they are able to access all those systems. So we took around 2.5 months for all this migration effort across 4 different environments, starting from dev, SIT, UAT, and then production. And this was really a success story. So finally, moving to some best practices and considerations for migration. So first of all, we need to understand that if the licensing models that are available. So for example, if we are moving to MuleSoft RTF on self-managed Kubernetes, so there are different licensing models available based on some of CPU limits or a number of physical cores or based on number of messages or flows that we consume. So we should be aware that what type of licensing models are available. And if we choose a particular deployment option, such as RTF or Cloud of 2.0, that we need to assess and estimate that what would be the number of cores required for that deployment option. We need to conduct performance testing to simulate real-world scenarios and assess the impact of API response times. Monitoring and tuning, we need to implement monitoring to track API performance post-migration. Fine-tuning configuration based on observed latencies. Obviously, we need to upgrade and test our APIs with latest connector versions and Mule runtime version. And also, we need to understand the specifics of DR. For example, if you want to set up DR in cloud or in on-prem, so how that affects the calculation of cores for DR. Most cases, compared to RTF, Cloud of 2.0 excels in administrative simplicity because it eliminates the requirement for managing infrastructure and having some Kubernetes-related skills. If you go with this RTF self-managed Kubernetes, it is recommended to select an Ingress implementation with enterprise level support because there are so many open source implementations also available, but we may not have the enterprise level support if we run into an issue. We should also incorporate CI/CD pipelines while migrating each environment. We need to update Log4j appenders to add logging for external logging solutions such as Splunk, Datadog, CloudWatch, etc. Because as compared to RTF appliance, we don't have like a built-in feature to forward logs to external log solutions. We need to inform clients if there is a update URL that they need to invoke, and if there are any TLS version changes. And finally, we need to review specific limitations for each platform. For example, persistent queues are not supported in CloudHub 2.0, and instead we use some external MQ solution or anypoint MQ. So we do also review the platform specific limitations. So these were some factors that we need to keep in mind. And with this, we will move to Mule Migration Accelerator. Over to you, Ali.
Thank you, Heather. Now, this was insightful. So, moving forward, I'm going to walk you through the Mule Migration Accelerator, and I'm going to familiarize you with this accelerator more in detail before we go towards the demonstration. Now, let's discuss why do we need to migrate using this Mule Migration Accelerator. The first thing is that this solution is powered by Royal Cyber middleware. So backed by Royal Cyber middleware expertise in middleware solution, our migration assistant ensures that you get a smooth and efficient transition from RTF to CloudHub 2.0 or any other RTF bring your own Kubernetes. It will give you a high productivity saver, so you can say goodbye to the lengthy migration process. Our tool is designed to save your time and efforts, allowing you to focus more on what matters the most, which is your business. We'll provide you with the migration summary report, and this comprehensive summary report tracks every step of migration process, ensuring transparency and accountability. Then you can migrate to any deployment target, which means that this Mule Migration Accelerator powered by Royal Cyber is designed to offer unparalleled flexibility in migrating your APIs and integrations to any deployment target, whether you are moving to on-premise infrastructure, cloud environment, hybrid setup, or containerized platform. The accelerator ensures a seamless transition. You can migrate using this tool 10 times faster. With our cutting edge technology, experience migration speed that is 10 times faster than the traditional methods, minimizing downtime and maximizing the efficiency. Then you can also view the migration history, access to your detailed history of all migrations performed to gain insight into your migration journey and facilitate informed decision making. It is a highly customizable solution which can be tailored during the migration process to suit your specific requirements, ensuring a personalized experience that meets your business needs. And then last but not least, you can migrate multiple APIs, which means that our tool is empower you to migrate multiple APIs simultaneously, streamlining the migration process and accelerating time to market. Moving forward, let's talk about the migration use cases. So as we've already talked about, that migration can be done to any deployment target, and these are some of the use cases that we have, which is you can move it from RTF appliance to CloudHub 2.0. You can migrate from RTF bring your own Kubernetes to CloudHub 2.0 migration. You can also migrate from RTF appliance to RTF bring your own Kubernetes. You can also migrate from CloudHub 1.0 to RTF bring your own Kubernetes. You can move from RTF CloudHub 2.0 to RTF BYOK. Then you can also migrate from CloudHub 1.0 to 2.0. And then you can also migrate from hybrid on-premise Mule to RTF hybrid bring your own Kubernetes, and then hybrid to CloudHub 2.0. So these are 8 different use cases that we support using this Mule Migration Accelerator. Now, using these Mule Migration Accelerators, we have identified some of the return on investments and benefits. So one of the benefits and the ROIs that we have seen is the faster migration, which will allow you to experience accelerated migration timelines, ensuring minimal disruption of your operations, which will obviously help you to save a lot of the cost. It is less error prone, which will help you to reduce the risk of errors with our automated migration process, enhancing the reliability of your migration process. Then we have some of the best practices, and we've got a benefit from the industry's best practices integrated into our migration tool, ensuring optimal performance and efficiency is achieved. We have this accelerator utilized in a way that it is very easy to use. So our user-friendly interfaces makes migration very easy, even for non-technical users as well. And we'll provide a better visibility of these migrated environments by providing visibility into your migration environment, facilitate easier management and troubleshooting. And then we have the approach, which is mentioned here. So we have a manual approach and an automated approach. So using the manual approach, all of these tasks are done manually, which are prone to human errors. It is time consuming at the same time. And these are not recommended because obviously, we are in the era where automation is the key to success. And then we have single APIs that can be migrated at a time, right? Whereas when you're using the automated version of it, which is this accelerator that we have, so all or some of the tasks are going to be automated. There will be a less chance that you'll get errors. You'll be quickly migrate a runtime Mule environment. It is highly recommended, and you can migrate multiple APIs at the same time. And that's what we're going to showcase in our demonstration today to you to ensure that you'll get the best benefit out of this accelerator. Now, for the purpose of demonstration, I'm going to hand this over to my colleague Minhaj, and he's going to take you through the demonstration. And once the demonstration is done, then we will, there is an offer that we have brought in for our customers today who are attending this webinar. So please stay with us after that. And then once the offer is discussed, we will also talk about your questions and answers from the audience. We'll take on these questions and answers, and then followed by the response of it. So over to you, Minhaj. Thank you.
Hello, my name is Minhaj, Technical Lead at Royal Cyber. Welcome to our demo of the Mule Migration Accelerator, a powerful tool designed to simplify the process of migrating APIs across different environments. Whether you're moving from Runtime Fabric to CloudHub 2.0 or upgrading from CloudHub to CloudHub 2.0, the Mule Migration Accelerator has you covered. In this demo, we'll walk you through the key features and functionalities of the Mule Migration Accelerator. We'll show you how to set up your migration, select the APIs you want to migrate, and monitor the progress in real time. Let's dive into the demo and explore the features of the Mule Migration Accelerator. The screen you're seeing right now is the login screen, where we're going to log into the AnyPan platform, where you're going to select the APIs from. So we're going to give in the server host. This is the client ID, and this is client secret. I'm going to give the organization ID. As soon as I click on the next button, I'm taken to the API selection screen, where I can select the environment, and I can select the source and target servers. The first flow that we're going to cover is the RTF appliance to CloudHub 2.0. So I'm going to select the environments accordingly. So now I'm going to select some APIs for migration. So during the selection, I can give multiple different configurations for the deployment. For example, on the target, if I want multiple replicas, I can change this to 2, 3, or whatever number I want. I can change the vCourse. I can also give a public URL based on the domain. And we can also update the desired state for selected APIs on source and same on the target. Which means if I do if I click on this and make it stopped, so this API that I've selected will be stopped on the source, which is RTF appliance. So once they are going to get deployed to the target, which is CloudHub 2.0, the same API that is deployed to CloudHub 2.0 will be stopped on RTF appliance. So I'm going to go to the migration screen. Here we can see the live logs and progress of the migration. As soon as I click on the confirm button, it will start the migration. So as you can see, we are able to see live logs. All these APIs are getting deployed. So I selected around 8 APIs. They're already deployed and getting started now. So we are waiting for the APIs to get started on the target. So we can also see that in the Anywhere platform that these APIs getting started as we are waiting over onto the Mule Migration Accelerator. So one of the APIs is started now. It's running. So now all the APIs are migrated and have started. Now we can go to the to view the report of this particular migration. So here we have a pie chart where it says 8 APIs got successfully migrated, and none of them were deployed with unknown status or did not get deployed. So showing date, the number of APIs, number of failed APIs and successfully migrated APIs, the source, target, and the list of APIs that we selected.
For the next flow, we are going to cover CloudHub 1.0 to CloudHub 2.0 migration. So we're going to select CloudHub on the source and CloudHub 2.0 on the target. I'm going to select a few applications. So notice that there are two more text boxes over here in case of CloudHub 1.0 as a source. So we're going to ask artifact ID and the version from the user. For this, we have, and version is this. We'll have to select one more. Alright, so let's go to the migration screen and confirm the migration. So both the applications are deployed and getting started on the target. Just like for the previous flow, we can check this on the runtime manager as well. So these two applications, RCF2 and F3, we have deployed and they are getting started. So both the applications have now deployed and started on the server. We can view the report for them as well. So If you see, two of them have been were selected for deployment, and they have successfully been migrated. The same things you're able to see here for the Cloud Hub 1.0 2.0 migration. The source is Cloud Hub, and the target is Cloud Hub 2.0. The next flow we are going to cover is RTF self-managed Kubernetes to Cloud Hub 2.0. So I'm going to select the source and target accordingly and select the APIs. So this API test hello RC is already deployed on Cloud Hub 2.0. So I've deliberately added this to show you how the error is shown if the API is already applied the same name on the target. So let's see how it works. So we're going to confirm the migration. So as you can see, one of the test hello RC API has not deployed, and there's an error saying the name of the application test hello RC is already used in the target. While the other applications are getting started on the target. Let's wait for them to be started. So one of them has started. Let's wait for the last one to get started on the target. So all of them have started and deployed on the target. Now we are viewing the report. So one of them failed to deploy, like we saw, because the name and the API being deployed already on the target. So three were selected for migration, two migrated, and one failed to migrate. There is source, the runtime fabric self-managed Kubernetes environment, and the target is Cloud Hub. So here we can see the error message as well for the SLRC API because it did not get deployed because of it being already deployed on the target. So it will show you all these details like error message, error code, and error. If you click on the expand icon on the table. The next flow that we are going to cover is RTF Appliance to RTF self-managed Kubernetes. We're going to select one of the APIs and confirm the migration like we did before. So the API deployed and is starting on the server. We can also check this on Runtime Manager. So this is the API I selected and this is the target. So it's applying, which means it's starting. So let's wait for the API to get started. So the API has started. Let's view the report. Here we can see the pie chart with the 100% success rate, as we selected only one API for migration and it successfully migrated. Source is RTF appliance and the target is RTF self-managed Kubernetes. So the other thing that we can do with this tool is you can see the history of all the migration that we have done earlier. So this is the list of all the migration that we have done. So if you want to see the report of those migration that you've done earlier, you are able to do that. This is a migration from RTF to Cloud 2.0. And so on. So you can even like filter it out based on source target. For example, I do this. So we've done a few of them like this with the RTF2 self-managed Kubernetes. You can also check against this, right? So previous one way back. So if I want to check one of these, so this is all that I can see here, and so we can filter it out based on environment as well, based on date, and against API name. For example, if I want to search against an API name which has a scheduler in name, so if I go into one of these, it will have, so this API is there with the scheduler in the name, so that's why this is being shown on the list. And there you have it. The Mule Migration Accelerator makes it easy to migrate your APIs between different environments with just a few clicks. We hope this demo has shown you how this powerful tool can simplify your migration processes and enhances your API management. Thank you for watching our demo. If you have any questions or would like to learn more, please visit our website or contact our support team. We look forward to helping you achieve seamless API migration with the Mule Migration Accelerator.